Good morning, grade 12s. Hope you're having a very good morning so far. Today we're going to be looking at a very interesting topic, and it's a topic about data. Remember from the previous lesson, we were doing concepts of GIS, and we looked at the definition of what GIS is, and we also looked at the different makings of a GIS system. And one of those makings that we looked at was data, the data aspect of GIS, and the fact that GIS needs data to be able to operate. Right, so today we're going to be looking at the different types of data, but before we do that, I just wanted to have a look at something and see if we are able to, put this topic into perspective. Right, so this is an image, a Google Earth image of the Earth surface. It's Joburg Springfield, but we can look at any other area because it's an interactive map. Right, so with this, I just want us to look at the map and see what features or what objects can we identify in the map. From the get-go, the first thing that jumps out is the fact that there is a dam, and it's called the Wema Pan. You can also see the roads, which are linear features within the map. You can also see things like this field, which I would think is an excavation site, or a mining area, or a potential new development. And we can also see buildings, different types of buildings and built-up areas. We can see stadiums, etc., etc., etc. So all of these things that we're seeing here are actual features that are on the Earth's surface that occupy space. And that is what we're going to be talking about today. Those are the things that I want you to be able to identify in a map and be able to bring to the GIS side as a data type. So going back to our lesson, what is important in this lesson is that we need to be able to define the two different types of data, which is attribute and spatial data. We also need to be able to identify these features on a spatial map or on the Earth surface, on an orthophoto map or topographic map. We need to be able to identify it, to be able to know that we actually know what it is. Right, so to start off, I wanted to start off with just the definition of what spatial data is. And when you think about spatial data, you need to be thinking about information about the location and shapes of geographic features. And that is well represented on the figure next to the intro, which breaks down different features into categories. One is vegetation data, the next one is buildings data, and then we also have data about the streets. And as per the earlier model, which we're looking at on Google Earth, we saw streets, we saw buildings, we saw different trees, we saw dams, etc., etc., etc. So in a GIS, that data, all of that data that occupies space on the Earth's surface is called spatial data. But it doesn't end there. So what else? The other thing we need to be able to see is that from this data that we're taking out, let's say for instance you have a buildings data. In that data you need to be able to know the types of building that you're mapping. As I mentioned, we have residential buildings, we have commercial buildings, we have malls, etc., etc. So you need to be able to give more context as to what that feature is. And giving that context requires you to use a different kind of data which does not occupy space, but rather is stored in a table. And that data is called attribute data. And by definition, it provides additional information about a geographic feature beyond just the location. Right? So there are different ways to represent spatial features on the maps. The image we were looking at before is an orthophoto map. So in that image, you see the feature as it is. However, when you're looking at a topographic map, which we've covered before, you are able to see that there are different ways we represent geographic features. Buildings could be represented in a certain way. Roads are represented using a certain symbol. trees, etc., use a certain symbol. Dams use different symbols, etc. So that's what we're going to be looking at, and what constitutes what, and why we represent things in a certain way. So with points, that's where we look at features that occupy a fixed position on the Earth's surface, right? So that would be things like trees, trig beacons, spot heights, and reservoirs. So it can be anything that just occupies one fixed position and only has one XY coordinate. That is the basic characteristic of what we would represent as a point feature. And then we also have other features that don't just have one fixed position, that occupy a linear position on the Earth's surface, which have one dimension, and that dimension is length. So we can already remember when we were looking at the image, we saw things like roads, we saw things like rivers, and all of those things have a linear dimension, and all of those things are represented using a line feature on the map. So we also have one other representation, which is a polygon, and I'm sure you've guessed already that polygons are where now you're looking at something with the whole dimension, a full dimension of width and breadth, and that represents features that can be demarcated as a boundary with area. That's the important part. It has to have an area, so the boundary has to be enclosed, which then means we're looking at things like built-up areas. We're looking at things like dams, which is the dam we saw in the example before. We're looking at vineyards, cultivated land, etc., etc. So when you look at this in sequence, we can see that when you first have a point, you have one XY coordinate. If you have 2 points that make up a linear feature, you have a linear feature which is now a line feature. So this could have multiple points joined up to make a linear feature. So when you're now wanting to digitize an area, you would then do the same thing, keep connecting until you complete the cycle, which would then mean that you now have a polygon or an area feature, right? So moving from that, we now going to look at what attribute data brings to the GIS system. Right, so attribute data is not just there for you to know what information is there. It's actually used for a variety of things that help us make decisions with the data. So when you look at attribute data, you think about the fact that you are able to now analyze the information that you've collected. You are able to see buildings that are old, say, for instance, that were built at a certain time, the buildings that have changed ownerships, buildings that owe money to the states, etc., etc. So those are all of the things that you are able to get from an attribute table alone. So from that, you are also able to symbolize features on a map using attribute data. And by symbolize, I mean when you look at a thematic map, which is like a typical map that uses symbology, thematic maps use a range of, say for instance, if you're looking at a heat map or a temperature map, it uses a range of temperature ranges, to be precise, to be able to tell you that in Joburg it's slightly hotter than Durban, in Brown, for instance, it's hotter than Parktown, Western Cape is colder than this area, etc. So by looking at that, you're able to make sense of what area has what temperature based on the themes, and all of the data. That ability of GIS to be able to give you that comes directly from an attribute table, and that is the main purpose of the attribute table, to give us that extra context. We can also use it to plot graphs. If we have numerical data, we use that numerical data to plot different graphs, and we can place them on the map or close to the map to give further context on what we're doing. Right. So lastly, what I want us to do is to look at the image on the side and try and identify the features that are labeled, and see if you are able to tell me whether that feature can be represented as either a point, a line, or a polygon. and try and find a reason for your answer, right? And I'll give you a minute to do that, and then we'll do it together and see if it works out. All right, so yeah, I think that should do it. So the first one is the education library, right? The library is a building, and by it being a building, it means it has width and breadth. So the building can be represented as a polygon feature. So if you got that answer, well done to you. Kudos. If you didn't, you will revise the slides, and we will all keep going. So the second one, the number 2 on the slide, is a pool, a swimming pool. Swimming pool can be represented as, you got that right too, a polygon, because it also has width and breadth. And then we move on to the next feature, which is number 3, road, which is a line, and then we go to number 4, which is a point. So on our next lesson, from this, we'll now be grouping these two features together and making sure that we are now looking at vectors and raster models. So you can go and look that up on your textbooks, and when we come back, we'll look at it in more depth. Thank you very much. Have a wonderful day.